Bismillahirrahmanirrahim. This is me, Miss Aisha Manzoor, and you all are watching my channel Chemistry Solutions. So, today in this lesson, we are going to attempt some tricky questions based on calculations of relative atomic masses. So, first question is from the paper 1 to October November 5070. So, in this question number 4 of this paper, a sample of element Q contains two isotopes. The diagram shows the relative abundances and relative masses of the two isotopes. So there are two isotopes. So total abundance is 6 of for the first one, first with the atomic mass 20, and fifth relative abundance gives 22. So how we are going to do it? Let me tell you. We will do it like this. We have to calculate the relative atomic mass of this substance is equal to 1 at 20, 1 divided by 6 multiplied by the atomic mass, relative mass is 20, plus 5 divided by 6, this value will be divided by 6, multiplied by 22. So this is the mass given at the position of relative abundance 5. So if we will calculate it, we will get the value 20 plus 5 multiplied by 22, it will be 110 divided by 6, and answer will be 21.7. So the correct option for this answer is the D. So next question is from May-June 5070 1 to 2024. So this question examiner report says students face little difficulty to attempt this question. How to calculate the isotopic mass with the isotopic masses? How to calculate the relative atomic mass? So this is a question, as you know, is little bit tricky. So how we will do this question? Let me tell it to you. First of all, we will calculate all x plus 2. There are 3 x plus 2 out of 12. So we can calculate all the circles here. So the way to calculate it like this: x plus 2, and there are 1, 2, 3x plus 2 out of 12. Plus how many x are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are x 9 out of 12. So this is the equation which we will first derive. So relative atomic mass of this substance we are calculating. It will become 3x plus 3 2s are 6, and then plus 9x and divided by 12. So if we will calculate the 9 plus 3 total, 12x divided by 12 plus 6 divided by 12. So if we will calculate it 12, it will be cancelled out, and x plus 0.5 is the answer. So our option which is correct is the A option is the correct for this MCQ. Next question is, the table shows the relative abundances of the two naturally occurring isotopes of bromine. Calculate the relative atomic mass of bromine to 1 decimal place. So the information which we have, 55% of relative abundance with 79, with 81 we have 45. So this one is little easiest question. You can use the formula. Relative atomic mass is equal to the isotopic mass multiplied by relative abundance Similarly again, plus isotopic mass multiply by relative abundance divided it by 100. This is the formula. So now we have to calculate the atomic mass. For 79 we have 55%, isotopic mass is 79, multiply by 55 plus isotopic mass 81, multiply by 45, then divided it by 100. So answer is 79.9, but we have to give the answer in one decimal place, then it will be 80. So this is the way through which we will calculate this question. So this one is little tricky question. A pure sample of element Y has a relative atomic mass of 62.4. Okay. Relative atomic mass is given to us. The table shows the sample consists of 3 isotopes. It means it has total 3 isotopes in it. The table shows the relative masses and percentage abundances of 2 of the isotopes. Percentage abundance of isotope is given 30 and 50. Relative mass of isotope is 60 and 50. So if 2 isotopes have 30 and 50, then 30 plus 50 will have 80%. So out of 80%, third isotope will have 20% of the isotopic mass. So now we have to calculate this X. We all know the formula how to calculate the relative atomic mass of the substances. AR, now isotopic mass 60. For the first isotope is 60, multiply by relative abundance 30 plus 65 multiply by 50. Now we have to calculate the relative mass of third isotope. It will be X multiply by 20. So we have calculated its percentage, divided it by 100. So now we have the value of atomic mass as well. So atomic mass which is given to us is if I will remove and write the value here, 62.4 is given to us. So this is the mass, 62.4 relative atomic mass is given to us. So now we have to calculate it accordingly. 62.4, this 100 will get multiplied here, and then 60 multiplied by 30, it will be 1800, I think so. Let me calculate it. Okay, 1800 plus 65 into 50, 3250 plus 20x. Now we have to calculate it. It will be 62400. 1800 plus 3250 is the value, that is the 5050 plus 2x. So 62400, we have to subtract this value 5050 to x. So x will be, if we will divide this value, 62400 minus 5050 divided it by 2, the value of x will be 59.5. So we have to, they are not asking about any significant figure. So 59.5, it means it has x, value of x is near about 59.5. The atomic mass for the third isotope is the 59.5. So this is the way through which we will do this question. So next question is, rubidium has only two natural occurring isotopes, 85 and 87. So these are the isotopes basically with 85 and 87. Proton, electron, neutrons we do not require here. We have bromine 85 with the atomic mass 85. Sorry, rubidium. We have rubidium with 85 and rubidium with 87. Yes, 85 and 87. The relative atomic mass of rubidium to one decimal place is 85.5. So AR of the substance is given to us, that is 85.5. Determine the relative abundance of rubidium 85 in rubidium. So we have to calculate the relative abundance of rubidium 85. So we can do this question. We have atomic mass that is 85.5. So you know that the relative abundance, first of all, isotopic mass will be multiplied by isotopic mass will be multiplied with the x. If we have to calculate the relative abundance of 85 multiplied by x, we want to calculate this x value, then 87 with this 87, mass of 87 multiplied by 100 minus x. Relative abundance which we are taking are basically out of 100 we are taking the values, okay, then divided it by 100. So multiply this value 85.5 multiplied by 100. It will become 85x plus 8700 minus 87x. So now how we will proceed on? It will become 8,550 and 8,700. Now 87, subtract this value 87x with 85x, it will become 2x. Okay, now we will subtract the value 8550. Let me subtract the values. Wait, bring this 2x here, and 8700, subtract the values 8550. X is equal to 8700 minus 8550 divided it by 2. Then the answer for rubidium, that is the 85, is 75%. It means if we will subtract 75%, rubidium 87 will have 25% relative abundance. So the correct answer is 75% for this question of rubidium 85. So this is the end of this these tricky questions. I think so that you people have learned it very well. Dear all, if you have learned even a single word, do not forget to subscribe my channel. So always remember that the consistency is the key of success. So signing off, Miss Aisha Manzoor.